Welcome to our video presentation of PHY150, and today we'll be presenting on chapter 3, capacitor and capacitor. Here are my group members. My name is Merikudes, and we have Ahmad Junaidi and Kristalin. The contents of this presentation consists of capacitors and capacitance, series and parallel arrangements for capacitors, energy storing, dielectrics, and real-life application of capacitor. In this video, the objective is to understand the concept of capacitance and capacitor, to understand the concept of adaptation for capacitors in different arrangements such as series and parallel, and lastly is to gain knowledge on capacitors for the importance or the application of capacitor. Capacitance and capacitors. Why and what is it? Capacitance is the ability of a system to store energy in the form of charges measured in farads, F. The charges are stored inside capacitors. Capacitors in general, the usage ranges from energy storage, timing circuits, filtering, or even general circuits design. Capacitance measurements are used to understand and optimize the performance and proper functioning of electronic systems. Capacitors, how do they look like? Inside the yellow box is a most commonly used capacitor. This capacitor is even found in devices such as portable radios. And on the right side is a fixed capacitor symbol inside a circuits diagram. Capacitors. Let's take a closer look to capacitors. Here you can see two plates, left and right. They are terminals, positive and negative. The positive and negative are based on the power supply connected. If the positive is connected to the left, then the left plate will be positive terminal, as well as negative on the right side. The plates do not touch each other. There is a gap between them. This gap is called dielectric. They act as an insulator. The plates cannot touch each other because otherwise no charges will flow through, as there are no charges separated in the first place. Next is capacitance. Capacitance is defined as C equals to Q over V. C is capacitance measured in farads. Q is charges measured in coulomb, C. And V is volt, or potential difference across the capacitor, V. The higher the capacitance of a capacitor, the higher the energy stored, and vice versa.
Hi, my name is Kristalina Chakre, so I will be explaining more about combinations of capacitor. So, when capacitors are connected in combination, they can be arranged in different ways to achieve various electrical effects. The two most common configurations are series and parallel combinations. When capacitors are connected in series, the same current flows through each capacitor, but the voltage across each capacitor may be different. The total voltage V total across the series combination is the sum of the individual capacitor voltage. The reciprocal of the total capacitance C total in a series combination is equal to the sum of reciprocals of the individual capacitance. When capacitors are connected in parallel, the same voltage is applied across each capacitor, but the current may be vary. The total current I total entering the parallel combinations um, is the sum of the individual capacitor currents. The total capacitance C total in a parallel combination is the sum of the individual
Hi, my name
capacitance.
is Ahmad Junaidi, and in this video I will present about electric energy storage. Electric energy storage is an electrical charge is stored in a capacitor. The symbol for electric energy storage is capital letter U. Energy stored in capacitor equation is U equal to half C times V, where C is capacitance and V is potential difference. There's also another formula which can be used. U equal to half QV, where Q is CV. And now I will explain about energy density. Energy density is the total amount of energy that can be stored in a given system, substance, or region of space. Dielectric. So dielectric constant is K. It's allow an increase in a capacitance and allow QE to flow or break down. And here are some equation for dielectric. And this is more about dielectric. First, reduce E. Charge in alignment create an E field with the material which oppose the original E field between the plates. Dielectric strength, maximum electric field which a capacitor can endure without breaking down, and constant K will depend on condition of dielectric.
Combinations of capacitors contributes a lot in real-life application. For example, communication systems like radio communication. In communication system, groups of capacitors are like helpers that make sure messages are clear and reliable. They act as filters, cleaning up signals by focusing on important parts and blocking out unwanted noise. These capacitors also help adjust the system to specific frequencies, much like tuning a radio to catch a particular station. They ensure different parts of system work well together, like making sure everyone speaks the same language in conversation. Additionally, they contribute to a stable power supply, prevent disruption, and help coordinate the timing of signals. Overall, these capacitors combinations are tools that make sure communication system operate smoothly and effectively.
Now we go into the conclusion. In summary, let's recall back what we have learned. Capacitance is the measure of ability to store electrical charge, while capacitors is composed of connecting plates separated by dielectrics. They are the key components in electronic for tasks like energy storage and filtering. Understanding these concepts is essential in electrical engineering. As that would be all, this is our references, and thank you for watching.
That's the end of our presentation, and we would like to thank Dr. Robin for guiding us with this project. Thank you.